Hi everyone and welcome to this video on set notation and sets of numbers. God, it doesn't get any more exciting than this. Well, actually it does. Well, maybe it doesn't. These are maths videos. Who watches maths videos? Well, you are, and if you can do me a massive favour and subscribe to my YouTube channel, it really does mean the world to me. My God, I say this at the start of every single video, but it's because I get like 3 subscribers a day, and that's really sad. So if you can subscribe, it just lets me know that you are watching. Right, what is this all about? Now, I've said Mathematical Methods Year 11. For those of you watching it around the world, don't worry about it. Set notation, sets of numbers is in pretty much every course I can imagine. It's just I'm recording it specifically for an Australian market, but the learning is fine. Right, shut up, Darren. Let's get on. Did I say I was Darren from Maffs Guru? I don't know that I did. You can go, Maffs Guru? Absolutely. My little corner of the interweb down here that I couldn't spell and thought was hilariously funny. Now, what are we going to do here? Right, this is a start of a brand new topic that really is massive, and I probably say that at the start of every video. Here are the learning objectives. Do you want me to read them to you? Probably not, but it is language based. And one of the things I'm going to say about mathematical methods is it is all in the language. The questions are written in a way that if you can see through the stupidity of the language, then basically you can smash this, because I promise you the basic learning is all the same. 2 things to smash. If you want to do well in this course now and next year, all you need to do is make sure you understand the language of the course and make sure your algebra is pretty good. And the way to get your algebra good is to practice, is to not give up. There's a story about a ladybird that I might actually release as a video one day that my daughter uses all the time at this moment in time. And she's 4. She doesn't give up. She just keeps trying because of that little ladybird. And you're like, what is he talking about, a ladybird? All right, easy, tiger. Right, recap. Now, as I've said here, it's the start of a brand new section of the course. There's not really a lot to recap other than all the stuff you've done before. Because fingers crossed, if this is valuable, it's going to build on all the previous stuff. These are like bricks. They're building bricks. When you get to year 12, please don't think we're going to teach you all this stuff again. We won't. We'll review it. We move on. We go deeper. So the best thing you can do now is make sure you put all of the time and effort into year 11, because year 12 will be much easier result. And if you get stuck, ask. Please ask. Send me an email. Send me, get in touch, and I'll do what I can to try and help you. These videos are here to do all I can to help you smash this course. Rightio, set notation. A set is nothing more. Now I'm going to read this because it's, it's really important. And I also want to prove I can read. I'm a maths teacher, but I do more than just numbers. A set is nothing more than a collection of objects. Yes, now I say objects there. Generally speaking, we're going to deal with numbers. But theoretically, in previous years, it could have been colours. It could have been political parties. It could have been car makes. It could have been all sorts of things, right? Now, we normally use a letter to stand for the set, and that is arbitrarily chosen, all right? We don't have to start it with A. Generally speaking, this could be given in a question. And what you'll notice is curly brackets. So important. The number of people who don't put the curly brackets and they lose marks as a result. Mathematical methods is about notation. It is about mathematically writing down the correct stuff. So here we go. There is a set of objects. 1, 3, 5, 7, and 9. The start of the odd numbers. Okay, that works for me. Yeah, or all the odd numbers between 1 and 10. It doesn't really matter. That will be given in the question, but curly brackets is important. Now, every single number in there is an element. Yeah, so if I now delete that highlighting for a moment and say, let's just highlight an element. There you go, 3 is an element. But how do we mathematically describe that? Well, we use the little E sign. Element. Yes, it even looks like an element, right? But not the letter E from, the alphabet. It's got to be that little beautiful curly. Oh, let's do it the right way for the camera. Can I do it the right way for the camera? That's it, backwards, whatever. All right, so we now know that 3 is an element of A. But what if it's not an element? What if I want to say, well, what about the number 2? Well, weirdly, we put the E with a line through it. Yes, and we'll make sure the line goes the right way. So 2 is not an element of A. All right, now, if you want to, download these from, mathsguru.com and put it in your summary book. Make sure you learn it. The more, it's like learning French, really. No, it's nothing like learning French because French is really hard to learn. I thought so. Anyway, now a subset. What about if we want just a couple of numbers or a group of numbers or some of the numbers or maybe all of the numbers? Well, we use contains within. Contains within just happens to be that little C there, and I'll put a circle around it as well so that we can highlight. So what we now know is that here, and again, remember the curly brackets, that the numbers 1 and 3 are contained within A. Ooh. Now, what about if we want some sort of set that's exactly the same as element A. We want a copy of it, for example, but we want to call it B. I don't know why in the world we would want to copy something. Well, we use a C with a little line underneath it. Yes, because that now says it contains all of the numbers. So B contains all of the numbers that are in A. And again, notice how this is like English just written shorter. Mathematicians are so lazy. We're just trying to write things much, much quicker. Right, let's keep going. So when we have two sets, there might be overlaps. What about, and we've done this in year 10. I know we have, yeah, but intersections, right? So when things intersect, there's an overlap. So we've got B, which is 1, 3, 5, try again. We've got A, which is 1, 3, 5, 7, and 9. We've got B now, which is 1, 4, 9, 16, and 25. What are those numbers? Quick quiz. Square numbers. Yes, congratulations. And I'm doing again. I'm looking at the camera, expecting you to respond to me. And what is going on in my head? Right. Now, in this situation, we can use the upside down N sign or the upside down U sign to stand for intersection. So if we are saying A intersected with B, basically we're saying, well, what is common? What numbers are shared between A and B? And again, if you look at A and B, that N is in the and. Well, if I've done this correctly, the only numbers that are shared are 1 and 9. And again, set squiggly brackets. What if they don't have anything in common? What about if there is no numbers in common at all? Well, we are going to say that they are disjoint. Yes, and again, these words will be thrown into exams, yeah? You'll meet it once. Now, if it's not in your summary book and you don't remember how to do this, you are automatically going to fall over if in an exam says, give an example of a disjoint set. All right? Now, what do we use here for notation-wise? Well, obviously we could use the closed curly brackets with nothing in them, all right? There's nothing in them. There's disjoint. Or we can use this 0 with a line through it, all right? That's O with a line through it, yes? Now, I know in computer programming languages, that would just be the number 0. But here, it stands for empty set. What about if we want to list all of the elements that are used in both A and B? All right? Now, I use the word A and B, but what I mean is all of the elements. Well, in this situation, if we want to use the union, it's when they are union, that's basically this U symbol. Oh, that makes sense, a union. Yes, A or B, and that's basically 1, 3, 4, 5, 7, 9, 16, and 25. So what I've really done there is taken the numbers from A and B and put them all together. Again, what am I going to say? Curly brackets. What about looking at elements in A but not in B? Oh, we use a, what is that, // backslash. A not in B, all right? So which of the elements in A are not in B? 3, 5, and 7. Again, can you see where we're going with these? Oh, yes. A number of questions. Now, Venn diagrams you may have met previously in years 10 or 9. All right, Venn diagrams normally have the square around them. Yes, and they have the little epsilon sign up there. But in this situation, let's take the examples from Cambridge. And thank you, Cambridge, for allowing me to use your examples. You guys genuinely rock. Cannot be more happy that you've allowed me to do that. Thank you, thank you, thank you. What do we do here? So, now in this situation, we've seen that the numbers in B are completely contained within A. So in that situation, this would be a prime example of B is contained within A. Right, so the numbers in B are contained within A. What about this one here? Well, this is probably looking more like the ones we'd actually done with before. And when we got here, so we got the numbers in A are 9, 7, 1, 3, and 5. The numbers in B are 5, 1, 3, 2, and 4. And then we obviously have this overlap, this intersection here. So Venn diagrams are really, really nice to be able to visually show sort of overlaps and unions and, where they, intersects and all those type of things. So let's have a look at examples. For A equals 1, 2, 3, and 7, and B equals 3, 4, 5, 6, and 7, find A and B. Oh, what does that N mean? Do you remember? Intersection. Aha. So let's change my pen color. So A and B is equal to curly brackets, the numbers that intersect. So A's got 1. Nope. A's got 2. Nope. 3. Yep, there was a 3 that's shared. And 7 and 7. Now notice that I had a pattern in which to do this. Yes, I went through each number one at a time. Makes life so much easier. Right. What about A or B or A union B? Well, curly brackets. These are the numbers that are in both A and B, including overlap. So we've got 1, 2, 3, 4, 5, 6, and 7. And there we go. That's it. Now, I know that my squiggly brackets don't look great. It's not an art competition, all right? And it's, in fact, it's not a competition. Don't judge. But the point of it is, it's just there as, you know, the examiner. If they're judging me in my handwriting, we're in a world of hurt. Right, what do we got next? For A equals 1, 2, 3, and 7, and B equals 3, 4, 5, 6, and 7, find A slash B. The ones that are in A, but not in B. The ones in A, but not in B. Well, we've got 1, 2, 3's in B, and 7's in B. So there we go. So those are the numbers that are in A, not in B. What about the other way around? B, not A. The ones that are in B, but not in A. Well, 3's in A. So we'd have the numbers 4, 5, and 6. All right. And again, getting used to that notation makes life a lot easier. Right, there are numbers everywhere. This bit here is huge, he says, right? Because basically we can classify numbers. And as we get into the course and more later on, you're going to have to know what real, rational, irrational, integers, whatever we've got, natural numbers, all of these are going to become massively important because you're going to use them in mathematical notation. For those of you doing specialist maths, wow, this stuff is everywhere. Right, so basically, understanding this, printing this off, putting it in your summary book, really important, but also learning it. So let's actually look first. We've got real numbers. Every single number under the sun is a real number. That includes everything from minus infinity to infinity and beyond. Yeah, decimal numbers, the works. Real numbers, everything. So what I like about the Cambridge book here is they gave this lovely ever-decreasing ovals. Yes, so basically this big circle here is the real numbers. It contains every single numbers. Then we get the natural numbers, okay? What on earth are natural numbers? They are positive whole numbers starting from 1. 0 is not a positive whole number, all right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, to infinity and beyond. Yep, that's a natural number. So here, those are those numbers there. Yeah, I've not done them in order. An integer, or as some people say, integer. No, integer. All right. And again, it is important to notice here that an integer is given as a Z with a double line. A natural number is an N with a double line. A real number is an R with a double line. That notation becomes important. Start using it now. So what did I say? An integer is basically a whole number. It can be positive and negative, and it includes 0. So -1, -2, -3, -4, 0, 1, 2, 3, 4, all of these numbers. Rational numbers, Q. All right, I don't know how you draw a double Q, but let's do that one there. Numbers which can be expressed as a fraction. All right, so numbers which can be expressed as a fraction are half. Most obvious example. Irrational numbers, those that cannot be expressed as fractions. So, for example, √2, pi, things along those lines. Okay, E, yeah, all irrational numbers. Yeah, now they don't actually have a little special letter. But if we look at our diagram here, what we notice we've got real numbers, we've got Q, which was rational numbers, Z was my integers, N was my natural numbers. All right, so they're subsets. That's a good word. Other things to remember or to notice is we have an R with a floaty plus. That's really important. That's a positive real number. Now, that does not include 0. Okay, a positive real number, because 0 is neither positive or negative. Yeah, it's just there. We have negative real numbers, which is R minus. Now, what that means is if I had a number line, for example, and there is my 0, that there is my R minus, and all of those numbers there would be R plus, yes? And real numbers excluding 0, this notation, I cannot tell you enough, becomes critically important. That backslash with a 0 in it, because there are lots of functions, lots of graphs that actually don't go anywhere new through 0. 0 does not allow them to work. So for example, if I gave you the function y is equal to 1 on x, if you make x equal to 0, what's going to happen? Well, you're going to get 1 divided by 0, which becomes undefined. So in that situation, this function here, he says doing it not highlighted, this function here basically is defined for all real numbers except 0. And writing that notation later on for function notation becomes critically important. Right, what do we got here? Describing a set of numbers. There are two ways of describing sets of numbers, because it's unlikely in life we're going to have a graph that's just going to have one point. All right, so if we look at the square root graph, for example, yeah, what does it have? It looks like that. It basically is defined from all values from 0 all the way up to infinity and beyond. He keeps saying that. Now, while I'm having a bit of a moment, have you subscribed to my YouTube channel? No. Could you? Please, because if you subscribe, it basically just tells me that you have watched this far into the video. In fact, watched the video. So few people watch maths videos. And I just sit there talking to myself. All right, even the dog's given up. He's 0. And yeah, that's the name of my dog. It's sad, I know. He's given up and gone, nah, I can't hear this anymore. All right, so if you can subscribe, that will be great. Leave a comment. Let me know how I'm doing. What can I do better? What could I do worse? No, don't say that. Right, okay, so one way of describing sets of numbers is this way here. All right, so you'll notice it's set notation. So you've got the curly brackets, yeah? So we open with the curly brackets, we close with the curly brackets. We start off with the letter, the pronumeral we're going to use to describe those numbers. So x, yes? And then what we do is we sort of list, or we use mathematical notation to say, well, what the values of x is. So in that situation, if we look at that, that says x, basically, it's a set of all x from 0 to infinity inclusive. Now, why is it inclusive? Because that there is, you know, less than or equal to or greater than or equal to, depending which way you read it. So, yeah. All right, so we'll look at the next one here. What have we got? All right, so this, curly brackets, set. All right, so this basically means that x can take real values except 0. So basically, x can be all real values, but it can't be 0. This one here is a funky one. I like this one here. All right, it's trying to trick you. Set of all natural numbers. Yes, all right. So, set of all even natural numbers, right? Because n is going to be equal to a natural number. So for the first natural number, I'm going to have 0. So my set is going to contain 2 times 0, which is going to be 0. Yeah? So my set in that situation, let's say it starts at 0. Let's say n is 1. Then 2n is going to be 2. When n is 2, it's going to be 4, 6, and so we go on. So writing it this way is certainly one way of doing it. But the one that's most likely to be used, or the one we use most common, is interval notation. It makes life a lot easier. And everything we do with interval notation relates to a curved bracket and a square bracket. That's it, right? Oh, and a comma. Don't forget the comma. A round bracket basically means that the number that is beside it is not included. Nah. A square bracket means it is included. So as I say here, if we look at this example here, we've got the open bracket, 0, 10, with a closed bracket. This open bracket means that basically, because it's by the 0, it does not include 0. The square bracket here means it does include 10. So this is going to be all the numbers from 0 to 10, but not including 0. Yeah? Now, when I say all numbers, they're all real numbers. 0, 0, sorry, not 0, 0.1, 0.001, 0.0001. There's a lot of numbers and I could be here all day. Those curved brackets are really, really important. A word of warning. Infinity is not a number. It's an idea. It's a construct. There is no defined idea of what infinity is. You cannot get to infinity. Okay? So what you can do is you always, when you get an infinity sign, is write a curved bracket. All right? If you write a square bracket by an infinity, you're automatically going to be wrong. So please don't do that. All right. So what have we got here? Again, thank you very much, Cambridge, for allowing me to use your examples. I took that directly out of your textbook just to say that there are ways of converting between the two. All right. So converting between notation style here, that is not a coordinate. That is an interval. And again, you want to be really careful in methods to make sure that you don't confuse when you're writing a coordinate and when you're writing an interval. Fingers crossed there shouldn't be an example where that would happen. So here, A, comma B with curved brackets means we're going to go from all the values from A all the way up to B, but we're not going to include A or B in that. So there we notice my inequality signs don't have that little line below. And again, we've got another example here where we've got square brackets. Is that square bracket and curved bracket? Yep. So what we notice here is that A is included because we've got my inequality sign with an equal sign, and that B isn't. So getting used to that notation, really important. But again, I think most times we tend to use interval notation. Rightio. Now, they said, my maths teacher said, a picture can say over 1,000 words. Really? Okay. We can draw number lines to show interval notations. We love pretty pictures, don't we? Of course we do. Right, illustrate each of the following intervals of real numbers. Now, real numbers include every single number, right? All decimal numbers, irrational numbers, everything. Right, illustrate each of the following. So we've got -2 to 3. So first thing I'm going to do is I'm going to draw a number line. This is for part A. And I'm going to say from -2 all the way up to 3. Now, I don't need to be too specific here, but are those values included? Am I going to include those values? Yes, because I've got a square bracket and a square bracket. So what I do is I do a coloured in circle, a coloured in circle, and a line between the two of them. And there we go, believe it or not, that is a number line that shows part A. If we look at part B, what do we have? So we've got a line again. Let's draw my number line. I've got -3 and 4. Is -3 included? No, it isn't. Why isn't it included? Because we've got that curved bracket there. So I'm going to do an open circle. Is the 4 included? Yes. When it's included, it's a closed circle. And again, we've got lines there. Now again, believe it or not, circles become really important, particularly on graphs, because an open circle at the end of a graph will mean that the point is not included. A closed circle means it is included. And that becomes important when we start limiting or restricting domains of graphs and functions. And again, these all lose marks in exams if you're not clever or close to doing it the right way. So let's do part C. Here is my number line. What have we got here? So we've got, what have we got? -3. And we've got to infinity. Well, there's no way I'm going to do a number of infinity. I can't put infinity on there. Is the -3 included? No, it isn't. So it's an open circle. And all I'm going to do is a straight line with an arrow on it. Say to infinity and beyond. And then part D. Oh, I've missed one. That wasn't part C. Oh, I only thought there was. So let's do that to part D. Let's do part C. We'll do my number line. We've got -2 to 4. Is that right? So -2 is not included. 4 is not included. Straight line between the two of them. Yep. And then what have we got here? -infinity to 5. So again, here's my number line, he says. Let's just delete that. Put a straight line. Come on. And what I got? We've got 5. And in that situation, I'm going to do a closed circle because it's a square. And I'm going to do an arrow that way, okay? Because I'm going to have all my values from 5 and down. Now, something else to notice with the interval notation is the smallest value is always on the left. People tend to mix that up in exams, and it's such a shame that you've got all of that working out right, and then you've just got the numbers the wrong way around. So it's always the smallest number on the left. And believe it or not, that is the end of this video. It was long, or it certainly feels very long. How long was that? 23 minutes. But again, it is so important content. Hopefully you found it useful. If you can, subscribe to my YouTube channel. Let people out there know that the content is here. All of the methods course is on mathsguru.com, or at least I'm recording it to be on there. Yes, there are downloadable lesson notes, exam questions, and all sorts of stuff. Let your teachers know if you can. If not, hey, hopefully I'll see you in another video. Take care. Please stay safe. Bye-bye.